Hello, this is the last and the third task for the internship project, the fraud detection system. Okay, what we have to do is gather the transaction data, process the data, then train the classification model, and check the model performance. Okay, so the problem is creating a classification model to detect the fraudulent transaction. So here we are importing the important libraries, the pandas, numpy, cbon, matplotlib, and the label encoder, importing the NLTK as this is going to be NLP type projects. So this is importing the NLTK libraries and downloading all the punctuation and the stop words. Starting with the reading of data, we are reading the CSV file. This is the top five rows is having the title, text, and the type, PAN classification model. Next, moving to the shape, we can check that it is having the 84 rows and 3 columns, and there is no null value present over here in the information part, and all are the object type. So total count for the null value is 0, and there is presence of one duplicate value. As you can see, the duplicated dot sum is giving the 1, which is that row is the row number 6 is the duplicate one. So what we can do is drop the duplicates and keep the first one. So we are having total 83 rows and 3 columns. So we are checking the value count, which is non-spam. The count is 57. The spam is 26. So it is a imbalanced data. So moving to the label encoding fit transforming the data, the type column. Here we are getting the 1 and 0, and for the value count we are getting the same. EDA to see the distribution using the pie chart, we can see that the highly majority of the data are not spam but some other spam. The 68% is not spam and 31% are spam, and for that we need to balance the data before the model building part. Gonna perform some analysis using the word count, character count, and the sentence count. Here we are counting the character on the title column and also the text column. So it's gonna count the each character and give you the count. This is the top 5 rows, and again if you can see that the word count using the word underscore tokenization, you can count the each word in the text. Word count for the text title is very less, so we can say that there's like so much of word in itself present in the word column, text column, so we can use that for the analysis and also for the model building, because we're gonna drop, we are not having the so much of word in the title column, so we can drop this. Okay, so moving next, we're gonna see the sentence count for the title and text. This is, you can see that the title is having 3 sentences for the first two and 5 for the text column, and the number of sentences is also very less in the title and the number of sentences more in the text column. So we'll move further with the text. We are describing this columns which we just added. So like the average word present in the word, the word is present is average 7 in the title, and average word present in the text is 161, so quite huge. Okay, the maximum count, you can see that the word maximum present is 20 words maximum present in the title, and 1276 in the text column. Not spam, we are taking that, and we are seeing the word count and the character and sentence count for the text column. So the maximum word present is 994 for the not spam messages. Okay, and you can see for the same, the spam messages, the spam messages total word count is 1276. This is actually true because the spam messages usually contain so many words, like the longer messages or mostly the spam one. We are visualizing the same thing using the histogram. This is the for the character. Okay, the number of character in the not in the spam messages we have assigned as red, and for the not spam it is blue. So you can see that it is lesser, the character number of character for the not spam it is lesser than this, sorry, the spam is lesser than the not spam, but you can see the highest account is going for the spam only. So for the same we can see this is for the word and red for the spam messages. So the words present in the not spam is more than the spam one, but still the highest count you can see is for the spam one. So with the correlation you can see if there is a correlation within the character, word and sentences of the text. So this is the type and the character. There's not much information we can get from this, but yes, it is slightly related with the sentence and the word than with the character. Data pre-processing part. So first we will lowercase the word and tokenize it, remove the special character, remove the stop word and punctuation, and do the lemmatization. So for using a NLTK, we dot corpus, we gonna import the stop words. This is importing the string, downloading the word net, and also the lemmatizer, installing the word cloud. This is the we are defining a function. We are giving the text column, and we are lowering the words. Okay, here this is the for the lowercase and word underscore tokenize. We are tokenizing the word. Again, in this we are having the y as empty list. We are giving the text. I will take each text value and see if it is alphanumeric. If it is alphanumeric, then it's gonna keep it. If it is a special character, I'm gonna remove it. We are clearing the y over here, and again seeing for the stop words. It's removing. If it is a stop words, then we are removing it, and again we are clearing the y, and again for the lemmatization of the words. So we are using the lemmatize. We are joining using the space. Done is stored the output, this whole output in a text underscore transformed underscore text. So this is the top 10 rows, and this is our final column transform underscore text. And for seeing the result for the 10th index, and this is not having any special character, all words are lowercase, and no stop words are there, and word has got lemmatized and everything. So for the spam word, we're gonna see the top frequently words which are used in the spam. So for that we are using the word cloud. Words like the video today, big game, take, click. These are the word which are highly used in the spam messages. And for the not spam, uh, for the mostly used word in the not spam messages, we are building a word cloud for that, which you can see. This is the customer service account, email company, log, projects team, please, address, and all other words which is present in the not spam messages. So what we are going to do is in the spam corpus, I'm going to take all the words I'm going to store in this spam corpus, and this is the checking the length of those words present in the, which are spam. This is the bar prompt for the spam corpus. For the spam words, the frequency of the click is very high. Today is the second highest. So these are the words which are mostly used in the spam messages. And for the ham, I'm doing the same thing, taking all the rows which are not spam and storing all the words in the ham, and then taking the length, taking the bar plot for the most common 30 words. So this is the most common 30 words for the not spam messages. So email company account, this type of the words which are highly used in the not spam messages. So next is the model building part. We are calling the TF-IDF. We are fitting transform the TF-IDF on our transform underscore text column, and we are getting the features. We are get underscore feature underscore name out, and getting all the features name. This is all the features, and view in the data frame format. This is the code. The feature is just going to be present as independent features, and y is going to be our target column. So here I am taking all the features which we just got and storing into the y, and y is nothing but the target column. So first we're gonna balance the data. For that I'm using this mode. The data inside the data set, which is not real, but to just balance the data, this mode uses this technique, and it uses the distance to add more data points to make it balance. So after applying this mode, like fit on a resample on the x and y, and if we see the value count of y, we are getting the equal count for the yes and no, like the spam and not spam. Split the data into train and test. This balanced data we're gonna split into the train and test, and some of the ML classifier. These are the logistic SVM, multinomial, and knife pay, decision tree, gain nearest neighbor, and the random forest, ADA boost, packing, and the gradient boosting, and storing into the variables. Taking a classifier where I'm giving all this model inside this classifier. Sorry, the CLF, this classifiers. Okay, so for the accuracy and precision score, we are calling a function train classifier. So what you're gonna do, give the classifier and train and test. We're gonna fit the all classifier on train and test. Sorry, the train data, and predict on the test data, and this will give you the accuracy and the precision score. As you can see that the precision and accuracy for the SVM model is 1 which is doing the overfitting. So we want a generalized model for all the classifier. To see the accuracy and precision, we are using this code where I am calling the function the train underscore classifier, the above one, and then the using the classifier and the data train and test data, and for the printing the name, we are printing the name of the classifier, printing the accuracy, and printing the precision, and appending it. Okay, so we're gonna get the final result for the each classifier. The accuracy is 100, precision is 100, canon for is not performing well. It is giving you the 47% accuracy. The precision is also low. So to visualize this in the tabular format, this is the code. Just taking the all the algorithm. Here's the classifier. I'm taking giving all the classifier accuracy. This will give accuracy and precision, and we are sorting on the precision. Just having the best precision. Okay. So the SVM is performing good and knife is good, but it is giving the 100% accuracy. It is doing the overfitting. So random forest model is something which is giving the accuracy of 94%, 95%, and precision is also good. And then here you can see that for the bagging classifier, the accuracy is decreased. So you can say that the random forest is performing well for this spam classification detection problem. So random forest give you the generalized model. This is not doing overfitting and performing well with the test and the train data. So our final model is going to be the random forest classifier. With this, I would like to end this video. Thank you.